the topic of today's lecture is arrays and probably loops. And once we're done that, we have functions, and then we're pretty much done with bash. And then we'll move on to the C part of the course. So it looks like it's going to happen, I guess, next week. We'll start the C part of the course. And then after reading week, you'll have your first test, which is only bash. Right? So that test after reading week is strictly on the bash part of the course. All right, so arrays in bash. I'm going to talk about arrays first, and then I'm going to talk about loops after talking about arrays. So bash has one-dimensional arrays. In bash, you use an integer index to access the elements of the array. There are some pretty significant differences between how a bash array works versus how arrays work in the languages that you have learned already. There's also a second form of array that bash 4 introduced. It's called an associative array, so it looks like a Python dictionary. We don't actually use those in this course. They're not hard to use. You just use it like a Python dictionary, basically. But I don't bother to talk about those in this course. Yes? Oh, sorry. What's going on here? Thanks for letting me know. There we go. Okay. So we're talking about integer indexed base arrays. So this says that bash arrays are 0-based, but that doesn't really mean much in bash. It only means that 0 is the smallest index that you can use in a bash array. There's no actual requirement that you start indexing your array at 0. So if you wanted to, you could index at 1 or 10 or 100. It's a bit strange the way that the bash arrays work. Right, so 0 is the smallest index you can use. There's no negative indexing. Is that true? I don't think there's any negative indexing. 0 is not necessarily the first index in your array. There's also no requirement that you label the elements in your array in a contiguous manner. Right, so if you start at 0, there's no requirement that the second element be at index 1. It could be at index 99 if you liked. So it's very strange the way that bash arrays work. So I recommend that you don't use a bash array that way unless you have a special reason to do so. Right? Use them the way you were taught in Java, or how you would use a list in Python. All right, so if you make an array variable, ARR, then the syntax is similar to what it looks like in Java or Python. You write ARR square bracket, and then I is your index, and that equals a value. On the left-hand side here, well, no, so I is the value of an index, right? So some integer value here. And so that assigns the value val to the element in array at index I. If ARR doesn't exist, bash makes one up for you, and then you assigns the value of val to that element of the index. If you want to get the value of an element in the array, it's the same syntax as before. It's $, and now you must use the braces around the array name. And so this is how bash disambiguates accessing a variable versus accessing a plain old variable versus accessing an array variable. Right? If you're accessing the element of an array variable, you need the braces, then you need the name of the array, and then you need an index inside square brackets. So there's assignment. That's actually array creation. So it creates the array ARR, assigns the element at index 0 to the string, assigns hello to the element at index 0 of the array. And there's accessing an element out of the array. Right? So $ brace ARR square brackets index. So that prints out hello. Again, space is important, so you can't do that. That doesn't work. Right? It ends up thinking ARR0 is a command. Weird, but that's what it thinks. So the spaces are important. There's no requirement, so I have to unset the array here. Hang on. And like I said, there's no requirement. Oh wait, actually it's in the next cell. Sorry, I don't have to do that here. There's no requirement that you start indexing at 0, right? And so here I'm going to unset my array back there. I'm going to then so remember that removes the variable ARR. I'm then going to make the variable ARR and assign its element at index 5. I'm going to assign the string weird to that element, and that works. Oh, sorry. There's a few things going on here. Okay, so down here it works, right? So that prints out weird. here, you have to be careful when you're accessing the elements out of the array, right? When you're accessing the elements out of the array, if you just write $ARR, that tries to access the element at array index 0, right? So with no braces or an index, you get the value of array 0. Now there is no value of array 0 here because we started indexing at 5, and so again, no error, right? All you get is the empty string here. Right, so bash substitutes the empty string for this unset value here, and you get the empty string here. There's no warning, right? So there's no warning that your element does not yet exist. Right, now I can go ahead and set, the element at index 0 to strange, right? If I print out just ARR, again, that gives you the element at index 0, right? It doesn't give you the whole array, and so that prints out strange. And finally, when I go to actually access the element at index 5 using square brackets and the braces, that's when you get the string weird. Right? So be very careful when you're using bash arrays. They don't behave the same way that you'd expect an array to behave in other programming languages. Okay, again, the braces are important. So if you write something like this, right, $ARR square brackets I, remember what $ARR does, right? That expands to the element at index 0, right? And now bash thinks square bracket I square bracket's just a string, so you end up with string concatenation in this place. So again, unset the array, set the first element of the array to strange, and now we get strange I, right? So that expands to the first element of, the element at index 0, which is strange. Right, that is just the string square bracket I square bracket. So you get strange I here. Right, if you want the element at index I, oh, this isn't going to work at all. Actually, what does this do? Oh yeah, that works. Even weirder. Okay, so if you want the element at index I here, you have to put the name of the array inside braces. Now, what's the value of I in this case? Well, the value of I in this case is 0 because it's unset. Right? Or it's the empty string. So, this ends up printing out strange as well, which is weird. Right? Okay, if you want to, you can declare an array using declare with the -a option. So this says X is the array, X is an array. That's all it says. You don't have to do this. You can if you want to. Right? So the declare statement lets you declare variables, and you can specify some information about their type. About their intended type. So for example, you can declare, using -i, you can declare a variable that's supposed to hold an int or an integer. Bash doesn't actually force you to store an integer in it. So here I've said, I'm going to make an array X, right? You don't have to use X as though it were an array. Everything works just fine the way it is. If you want to declare an array and set its values and set its initial values, you can do so using round brackets. So y equals round bracket 10, 20, 30 gives you the array of length 3, whose values are 10, 20, and 30. When you do it this way, bash starts indexing at 0 and increments the index by 1 every time. Again, you don't need to use declare. You can if you want to, but you don't have to. That works just fine. So you can just make up a variable name and create an array using round brackets, or set the elements of the array using round brackets. So here we get the array of length 1. Its first element at index 0 is the string hello. There's a second array that's got 5 elements in it. Starting at index 0, the values are 0, 1, 2, 3, 4. If you want to, you can specify the index explicitly with square brackets and an equal sign. So this says that array 3 has 1 element in it. The element is at index 1, and the element is the string goodbye. There's no requirement that the indexes you specify be in any particular order or be contiguous. So you don't have to go in steps of 1. So this makes an array containing the strings weird, weirder, and weirdest. The element at index 100 is weird. The element at index 0 is weirder. The element at index 1 is weirdest. There are no elements at indexes 2 through 99. And this does work if you run it. And if you printed out the elements, it would also work. Okay, so that's strange. That's a little bit odd, but you might imagine there's a use for it. That fourth example is very strange. I'm not sure, I can't come up with an example when you'd actually want to do something like this. Someone can probably figure one out though. Okay, so you've got an array. You might want to know how many elements are in the array. So bash arrays do know how big they are, which is nice. If you want the number of elements in the array though, the syntax is very strange. Right? So the number of elements in the array, you get it by writing that. Right? So $, then the brace, then the hashtag, then the name of the array, then a square bracket, and then the symbol at inside the square brackets. Right? So that's very cumbersome to get the length of the array. That's how you would do it if you need it. Right? And so to get the number of elements out of these 4 arrays, right? $brace, hashtag, name of the array, square brackets at. Right? And this will print out 1, 5, 1, and 3. Right? 1 element there, 5 elements there, 1 element there, 3 elements there. Okay, so that one you must commit to memory because that often shows up on a test of some kind. Okay, so what the heck is this at thing? So what does that mean? So it turns out there's an at and there's also a star that you can use as a subscript. And they mean something similar, but they're different, but subtly different. They have a similar but subtly different meanings. So if ARR is an array, then at as an index and star as an index, they both result in an expansion of all the elements in the array. Right? So in other words, they produce a string containing the first element of the array followed by a space, then the second element of the array followed by a space, and then the third element of the array followed by a space, and so on and so on and so forth. Right? So that's if you use them the way they're written. Right? So unquoted. They both result in the exact same thing. Right? You end up with a string made up of that. And all of the elements are unquoted. Right? So either expansion is fine. So if you need all the elements of the string, out of the array as a single string, you can use either form as long as you know for sure there's no special characters inside the strings in the array. Right? So there's no spaces or funny characters, right? Or symbols. Okay, now if you have reason to believe that your array has strings in it that might have unusual symbols, in particular, if your array contains a bunch of file names, you probably have to quote the expression instead. Right? So almost always you end up using that form there. Right? So quoted $ARR at produces a list of all the elements in the array where every element is itself quoted. Right? So every element gets expanded as a separate word, a separate quoted word. Right? So if ARR0 contains a file name, it's a quoted file name now. Right? So if you wanted to process every element of the array, you want to open up each file or do something with each file, right? That's what you should. That's the form that you should be using there. If you don't use this form, right? So if you don't quote, remember you end up with something that looks like that, right? The unquoted first element of the array. If there's a space in that name, then you end up with what looks like 2 different file names, right? The first part of the file name followed by a space followed by the second part of the file name. So if you try to process this list of elements using a loop, you'll end up processing or trying to process an unnamed, an unexisting file, or worse yet, you end up processing the wrong file. Okay, so that's the at. Finally, there's the star. So you can also quote the star, and this one has a different meaning yet, right? So the quoted version of star produces the same string as the unquoted version, right? So in other words, it produces the exact same thing as that or that, but then it quotes the entire string, right? So you can imagine that that entire string ends up being quoted. So you end up with one string containing all the elements of the array, right? All right, so let's look at, so in the next 4 cells, it shows you the difference between them all. This also uses a loop. So don't mind the loop. I'll show you how to write a loop in a few minutes, right? What's important is that part there, that part there, that part there, and that part there. Right? All the loop is going to do is it's going to process each element of the highlighted part. Okay, so we have an array. It contains 3 strings in it, right? And the strings have spaces in them. So when you process it with this loop, what ends up happening, so I guess first of all, the expansion, right? That produces a space dog space, a space cat space, a space fish. Nothing's quoted. So the loop processes each word in the string where the words are separated by a space. So you end up with a space dog, a new line dog, new line a, new line cat, and so on and so on and so forth. Right? So 3 strings, but you end up with 6 lines of output. Right? So that's using the unquoted star expansion. The unquoted at expansion does the exact same thing. Right? So 3 strings, 6 lines of output. And so this is a case where you probably want to quote the at version. Right, so remember what that does, that produces all of the strings of the array, all of the strings in the array, but it quotes each string. So now you have the quoted a dog, the quoted a cat, and the quoted a fish. So when you print those out, you get 3 lines, which is probably what you wanted. Right? The quoted star expansion gives you all of the strings, right, and then wraps up everything together, wraps up all the strings with a pair of quotes. So you end up with 1 string. So that prints out a dog, a cat, a fish on 1 line. Right? And so that's the difference between the unquoted and quoted versions of the at and star expansions. Right? You almost always want the expansion that's highlighted here, right? Especially if you're processing a bunch of files, a bunch of file names, sorry. Right? It's important that you don't do word splitting or any sort of file name expansion on the strings in the file that represent the file names. All right. What about the indexes used by the array? So because you don't have to start indexing at 0 and because you don't have to use a contiguous sequence of indexes, if for some reason you need the indexes of the array, Bash needs to give you a mechanism to give you that, to give you the indexes. So the mechanism is similar to getting the number of elements out of the array, except here you use the exclamation mark. Right? If you always index your arrays starting at 0 and going in increments of 1, you generally don't have to worry about this. You can just get the number of elements in the array, start counting at 0. If for some reason you've decided not to do that though, and you want the indexes, that's the way you get them. Right? So, oops, sorry. That thing there expands to all of the valid indexes in the array, starting at the smallest index. So here we're going to get 0. For the second array, we're going to get 0, 1, 2, and 3. For the third array, we should just get 1. And for the fourth array, we're supposed to, I think we get 0, 1, and 100. And we do. So there you go. Right. So a bit unusual to have to use this. You only need to use this if you don't actually know that your array is being indexed, how your array is actually being indexed. Okay, so here's an example of using that, of using the exclamation mark to get the indexes out of the array. You don't have to do it this way, right? This is just showing you an example. Our array here is indexed starting at 0 and goes up in increments of 1. And so in this case, it's probably easier to write a regular loop that I'll show you shortly. But this works just fine. So this is going to write a loop that indexes over 0, 1, 2, 3, 4. Right, so that's what that expands to right there. Right, and so you get 0, 1, 2, 3, 4, January, February, March, April, and May. Right. Inside the loop, we're getting out each month, right, by accessing the name of the array with $, and the braces, right, using an integer index here. I'm uncertain if this has to be if you can just use an I here or not. It seems to work in the notebook. I don't actually know what the rule is here, so I don't know if you have to whether or not you can access the use an index inside square brackets. I don't know if you need the $ or not to get the value of the index. Here it seems to work. I don't know the definitive answer here. And so normally I put the $sign in. So watch out for that. I'm not 100% sure if it's required or not. I should look that up at some point. Okay, finally concatenating arrays. Oh no, there's a couple of things. Can you join two arrays? The answer is yes. Can you join an element of the array? Can you add a new element to the end of the array? The answer is yes. But you have to be careful about adding an element to the array. Right? So Bash lets you concatenate arrays together. It doesn't let you concatenate a single element to the end of the array. But you can get around that limitation by making an array out of the single element and then concatenating that array to the end of the array. So array 1 plus equals followed by some array, followed by some array will concatenate the elements of the second array onto the end of array 1. Right? So notice how we're doing the concatenation here. Right? This is very strange. Right? We're going to expand the second array using the quoted at form. Right? Remember what that gives you? It gives you the list of words. Sorry, the list of strings in the array. Each string is quoted. Right? We create a new array out of that list, and then we concatenate that entire array onto the end of array 1. So A and B. So A is the array 0, starting at index 100. B is the array 5, 6, 7, starting at the array index 0. Right? If I concatenate B to the end of that array, we end up with the array 0, 5, 6, and 7. Right? Where were these concatenated to? Right? So it turns out they're concatenated at indexes 101, 102, and 103. Right? So as far as I know, when you do the concatenation, there's no way to specify the indexes of the elements after the concatenation. Right? So it simply adds 5, 6, and 7 to the end of A, starting at index, and A starts at index 100. So the 5, 6, and 7 get added at indexes 101, 102, and 103. If you want to concatenate a single element to the end of the array, you just make an array out of the element. Right? So here I've got some string elem. I turn it into an array, or I produce the array containing that element. Right? Round brackets makes the array. Don't forget to quote elem, right? Because if elem has spaces in it, you'll end up with an array having more than one word in it, or one element in it. So quote elem, that makes the array. That concatenates that element to the end of the array. So there's January, February, March, and we can concatenate May to the end by making an array out of May, like that, right? If you've got a space here, so May, June, let's do it this way, like that. That works fine, right? If you take the quotes away, sorry, this one doesn't do what you want it to do, right? That has an array containing 1, 2, 3, 4. This was quoted, so 5 elements in it, right? That's probably what you wanted to do, right? That produces an array with 1, 2, 3, 4, 5, 6 elements in it, right? So quoting is important, but remember, you have to remember why you're quoting. Right? In this case, I really do want the array with 2 elements in it. If you quote that string, you end up with an array with 1 element in it. Okay, interactively reading elements into an array. So there's a command in Bash in the shell called read. So this is a built-in command. Read will let you read text from standard input. Read's funny, so it doesn't treat quotes as preventing word splitting. So quoting the elements on the command line doesn't work if you use read. So read's a bit odd. So read's designed to read lines of input into an array, right? So it'll read the text on a line. It'll perform word splitting on that line and insert the elements, the resulting list of words into your array. Right? -p lets you specify a prompt. So here, enter a list of elements. Right? The -a says read read in the line, split the line using word splitting, and then store the elements in ARR. So I guess we can try that. So I can't do this in a notebook because the notebooks don't let you do, don't have any standard input up to them. So you have to do this inside of in my shell directly. Okay, how do I paste here? This isn't going to work, is it? No. There we go. Okay, so enter a list of elements. So 1, 2, 3. Right, press enter. Oops, sorry. Dollar number ARR at. So how many elements are in the array? There's 3. Right. What are the elements of the array? So I'm going to do it this way. Dollar ARR star or at. Oh, sorry. Right. Oh, sorry. I need the braces. Right. So get the expansion of all the elements in the array. Print them out until you get the elements 1, 2, 3. Right? If you want to look at them individually, there's 0. There's 1, and there's 2. Right? So if you want to read something from the command line, so if you want to write a program that reads something from the command line, you can use the read command to do so. You can also instead of reading from the command line, so instead of reading from standard input, you can read from a file. And so the standard way to do this is to use the command called map file or read array. And that's a built-in bash command that will read each line of the file. And I think it stores, read one or more lines standard, stores each line as a separate array element. Right? So read each line of the file, store each line as an element of an array. So here is an example of a file containing some student information. Right? So there's a header that explains what information is in the file. The lines of the file are just student number, comma, last name, comma, first name. Right? And so that little program here will read in each line of this file. Right? So there's map file. Map file needs a redirection here, right? Yes, it needs a redirection here. Right? So this reads the contents of file into an array called students. This explains -t removes the new line character from the end of each string. So if you don't use -t, when map file reads in that line, it also reads in the new line character that's sitting at the end of the string, right? So \n is sitting at the end of that string. And then it'll also store that character as an element of your array. So the second line of the array would be 1, 2, 3, 4, 5, comma, par, comma, jack, jack, new line. You normally don't want the new line as part of the string. To drop the new line, you use the -t option here. This thing runs a loop. It prints out each element of the array, right? And so you get the first line, the second line, the third line, and the fourth line of the array. And that's what we need to know about arrays, right? So very quickly to remind you the important operations. Number of elements is I guess that should have been the first one. Number of elements in the array, $, brace, hashtag, name of the array, square brackets, at, right? That's awkward, but that's just the way it works, right? Indexing works for assignment. Indexing works the way you expect it to, right? When you want to get the value, you have to remember to use the $sign and the braces around the name of the array and the index. Subscripts. And don't forget what the subscripts at and star do. Normally, if you want all of the elements out of the array as a list of strings, right? You use the at expansion and you quote it to prevent any unwanted behavior of special characters and the space. All right, so that's the arrays notebook. Any questions about arrays in Bash? Yes?
Are we allowed to have arrays inside of arrays?
Can you have an array inside arrays? So as far as I know, the answer is no. So everything, I think, everything in Bash is a string. So I don't think you can really store an array inside of an array. Yeah. Yep.
As I guess you store a string representation of an array inside an array.
Sure. Yes. So you could put the strings of an array as separate elements of an array. That's no issue, right? Anything else? All right. Now that we've got arrays, so we've got a collection of stuff, now it makes sense to actually talk about a loop. If you look online, you might see, so if you look online about Bash loops, you'll often see stuff or advice saying you probably shouldn't use loops in Bash. The idea is that in Unix or Linux, you generally don't want to loop in the shell itself. If you need to do something with, say, every element of a string or every element of a file, there's probably a command that does that for you. The command's probably written in a much faster language than the shell scripting language. And so you'll often see advice saying loops probably shouldn't be in Bash, or you shouldn't be using them in Bash. Nonetheless, they do turn out to be useful for some programming problems. So we'll tell you about loops, right? Okay, so Bash has 4 types of loops. There's an until loop, there's a while loop, and there's 2 types of for loops. The while loop works the way you expect it to, right? While some condition is true, run the loop. Until is a bit unusual. So there's Python and Java don't have until. The until loop runs as long as some condition is false. Sorry. Yes. So until loops as long as a test command has an exit status that is not 0. So remember, not 0, exit status not 0 means something has gone wrong. So it normally indicates false in Bash. So we'll show you an example of until in just a second. While runs as long as a test command has an exit status that is 0, right? So while something is true. Right. We have a for loop that looks like a for each loop in Python and Java. And then you've got a for loop that looks like a counting style loop in Java. Break and continue work the way you expect them to, except the Bash versions can specify which loop to exit out of. In languages like Python and Bash, in Java, if you have a nested loop and you break inside the nested loop, that breaks out of the loop it's defined in. Bash lets you break out of any loop that you want. So if you have a triply nested loop, you can break out of all of the loops at once if you need to, from the inner loop. Okay, so remember how conditions work in Bash, right? So conditions in Bash are just commands, right? If the exit status of the command is 0, then that's considered to be true. If the exit status of the command is not 0, that's considered to be false, right? So an until loop runs until a test command succeeds, right? So as long as that condition is false, the until loop will run, right? So until false runs forever, right? The while loop runs as long as this condition is true. So while true runs forever. Right? This double square brackets and the double round brackets, they both work as commands, right? So we saw the double square bracket in the last lecture. The double round brackets we also saw in the last lecture. So that's an arithmetic condition of some kind, right? So if you want an infinite loop, you can use the square brackets and the double round brackets as well, right? A equals B. So remember what that does, right? That does string comparison. So that compares the string A to the string B. A is not equal to B, and it never will be, right? So this loop runs forever, right? Until this condition becomes false, right? Sorry, until this condition becomes true, run the loop, right? So that loop runs forever. Right? Remember what minus n does inside of square brackets, right? Minus n checks if a string is empty. So is the string ABC empty? The answer is no, right? So while not empty, minus n is not empty. So while the string ABC is not empty, do something, so that runs forever. Right? Double round brackets lets you use an arithmetic condition. So As long as, until 2 is less than 1, do something, so that runs forever. While 1 is greater than 0, do something, right? So that also runs forever. If you want to count from 0 to 10, there's a bazillion ways to do it. Here's 2, right? So until your count is less than 0, right, print the count, and then decrease the count by 1, right? So 10 down to 0. Using a while loop instead, right, while your count is greater than -1, print out the count, decrease the count by 1 each time, right? There's lots of ways to write this line, right? Here I've written as count equals and then some arithmetic expansion, right? You don't actually need the expansion. You can just write count equals like that, right? That also works. Or you can write count minus minus, that also works. Right? Okay, this is the next script is the Collatz conjecture. So if you don't know what the Collatz conjecture is, it's a mathematical conjecture that says the following. So if you start out with some positive value n, then if you repeat these 2 steps here, the conjecture says you will eventually reach 1. Right? So start out with some positive value n, and apply the following rules repeatedly. So if n is even, then you take n, divide it by 2, and put it back into n. Right? If n is odd, you multiply n by 3 and add 1. Right? So if n is even, n decreases. If n is odd, n increases. The conjecture says you will always reach 1 at some point, despite the fact that whenever n is odd, you increase the value of n. No one actually knows if this conjecture is true, which is why it's called the conjecture. But mathematicians think it's true. And so they've actually tried values as large as 2 to the power of 68. So someone's actually written a program that's actually checked all values of integers up to 2 to the 68 as of 2020. It's probably higher now. And as far as anybody can tell, it always reaches 1. If you can prove that it does in fact reach 1, you'll probably win some money. So here's an example of how you can do this, how you can write a bash script to compute the Collatz conjecture. This is a nice example because it's got a bunch of error testing in it, right? So we talked about loops, we talked about conditions, so this has a bunch of condition checking here, right? So you're supposed to call this by passing in a number, right? So collatz.sh pass in some integer value, right? So this tests the integer value, right? So this tests if you have, if you actually passed in a value or not, right? So if the number of command line arguments is 0, print out an error message and exit, right? Otherwise, assume that the first command line argument is the integer value that you want to test with the Collatz conjecture. Right? Now we want to test, is that value actually an integer? Right? And so that's one way to do it. Right? We're going to use a regular expression. Right? Our regular expression is going to be the regular expression for a signed integer. Right? So remember how this works. The caret is starts with, right? Inside square brackets, we've got minus and plus. So our string has to start, can start with a negative sign or a positive sign. Question mark means 0 or 1 of the previous atom, right? So we can start with we can start with no question mark, no plus or minus sign, or exactly 1 plus or minus sign. 0 through 9. So any one of the digits. Plus means 1 or more. So this matches any signed integer value, right? Where the sign is optional, right? So if that thing matches, we want it, if it doesn't match, to test the error condition. So exclamation mark in front of everything to negate the value, right? So if it's not an integer, print out it's not an integer. If the value is less than 1, we can't use that either. Collatz conjecture only works for positive values, right? And then finally, we're going to print out the value, and then we're going to write our little loop, right? So as long as that value is not 1, we want to do something, right? If the value is even, right, divide the value by 2, store it back in the value, right? Otherwise, multiply the value by 3, add 1, and store it back in value, right? And if you run that, so if you run that for say 1, obviously we start at 1, so that stops. If you try it for 2, it divides 2 by 2 and then gets to 1, so it stops, right? Let's try 10, right? So 10, then you get the 5, so now you multiply by 3 and add 1, so now you get to the 16. As soon as you hit a power of 2, it's going to, it'll eventually get to 1, right? And if you try 27, you end up with a surprisingly large amount of output, right? Whoa, come back, right? So 27 produces many, many, many lines of output, right? But it eventually does get to 1, right? And so the fact that small numbers can produce lots of lines of outputs leads to the uncertainty of whether, or well, actually leads you to the conjecture, right? Does this, can you always reach 1 given given any positive integer value? Right, and so there's a nice example of that summarizes everything that we talked about in the past 3 lectures. Okay, so that's the while loop and the until loop. For loops are normally the loops, that's not true. While loops are pretty common, for loops are probably slightly more common. Until is a bit unusual, at least for the way I think in programming anyway. So Bash has 2 types of for loops. There's a for each loop. The for each loop runs over a sequence of runs over a list of strings. Right. So if you read the GNU Bash documentation, it refers to a list all over the place. Right. So whenever you're reading the documentations, the word list shows up all over the place. There is no list in Bash. Right. There's no data type called list. So when they see list, what they mean is that it's a sequence of white space separated strings, right? So A space, B space, C space, and so on and so on and so on. For each loop, we'll do something for every element in a list, right? So for example, for each name in some list, do something do something with this with the variable name. Right? So the variable name takes on the value of each element in list. So for example, that's a list, right? It's a sequence of space separated strings, right? So 10, 9, 8, 7, 6, 5, 4 down to 0 is a list containing 11 elements in it, right? Your for loop, your for each loop will do something with every element in that list, right? So you just pick a loop variable, I'm calling it I, right? Use the keyword in just like you do in Python, right? Inside the loop, I just refers to each element of the list taken in sequence. So that also counts down to 0, right? If you quote this thing, right, you have a list of size 1, right? Your list is the quoted string 10 down to 0. So your for loop runs once and it prints everything out on 1 line. Right. If you want to do something with every element in the list, you probably don't want to quote it in this case, right? Or you don't want to quote everything. You might want to quote each element, but you don't want to quote everything, right? So the list of strings you can get from any expansion. So here I've got a string, it's quoted. There's lots of spaces inside the string, right? Now notice what happens here. So I'm going to use the value of str, but I'm not going to quote it. Right? So because str is not quoted, right, you take the value of str, which is all of this stuff, right? Then you perform word splitting, right? So you end up with the list containing this, then is, then a, then string, skip over all the repeated spaces, then with, and so on and so on and so forth, right? So here we're using a parameter expansion to remove all of the repeated spaces in the string, right? And you end up with each of the individual elements, processing each individual element, word of the string, right? Intentionally unquoted in this case. If you quote it, right, you get 1 string. This one seems weird, right? So here, the original string has lots of repeated spaces in it, but when you print it out, all those spaces have disappeared, right? What's happened? you've got another unquoted s here, right? So again, you substitute the value of s, which is all of this, right? First time through the loop, it's all of that. It's unquoted, so bash performs word splitting, right? You end up with the list that looks like this, right? So if you really wanted to print out the original string in this case, you have to quote the loop variable as well, right? And now you get that. File name expansion also produces a list of file names, right? Or a list of path names in this case, right? So here, I'm going to look in the scripts directory inside the loops directory for all of my shell scripts, right? Notice each time through the loop, I'm quoting script in this case. I have to quote script because my shell script, these file names might have unusual characters in them, right? So there we go. So we got a bunch of, we've got a bunch of file names there, right? You have to be careful about the expansions in bash, right? So if a bash expansion, I think it's here, yes. If a bash expansion produces no result, then you end up with the original string defining the expansion. So that's an expansion right there, right? It's an unquoted string containing a star in it. So bash thinks you want to do file name expansion here. So it's trying to find all of the files ending in PDF in that directory, right? There are no files ending in PDF in this directory. So the result of the expansion is the original string itself, right? So now I get the original string, star PDF. This is a problem if you assume inside your loop that this is an actual file name, right? So now you try to process this file, and that's probably going to barf when you try to process that file, right? So an unmatched expansion produces the string defining the expansion itself in this case, right? So be careful of that, right? Brace expansions also produce a list of strings, right? So we don't really use this much in this course, but remember what this does. This produces the string 10 space 9 space, this produces a list of strings, sorry, 10, 9 down through 0. And so that's yet another way to count down from 10 down to 0. Sorry. And finally, you can use a command substitution to produce a list of strings, right? Pretty much every command, everything in bash produces produces a string or list of strings. So you can use most commands here to generate some sequence of strings, right? The sequence command produces a sequence. In this case, it starts at 10, goes down by 1 each time to 0. So it's start value, increment, stop value. So this is yet another way to count down from 10 to 0. Don't use sequence in this case, right? If you want a loop here, use a loop. Use a counting style loop. You should generally avoid using sequence to perform counting, right? The problem with this is that this is a command substitution. So bash has to start another shell to run the sequence command, take the output from the other shell, and then insert it into here, right? That's wasteful for just counting, for just writing a loop. Right. I guess we'll stop there. I think we're out of time anyway. Yeah, we're out of time. So we'll finish up this lecture in the next, so we'll finish up the rest of this notebook in the next lecture.